So students, let us discuss about the properties of magnetic lines of force. Here the first property is directed away from a north pole and directed towards the south pole, and each line is a closed and continuous curve. As you can see from the diagram, this is a diagram is already drawn of a bar magnet. These are the lines of force with the help of this magnetic needle. As you know about this needle, this is when you place a magnet here and you will allow this needle to move freely, and whenever it points in a particular direction we will put a dot there, and then after putting dots we will join those curves and we will get this complete diagram. So this is for a bar magnet, okay, and this is the north pole and this is the south pole. I have drawn the outline here, and these are the lines of force. The first property saying that the lines of force always start from a north pole and end on the south pole, okay, and these are all closed and continuous curves. Closed and continuous means it is not like they are starting from here and ending here. They are again moving through the body of the magnet. Also you can see as this paper is limited, so these curves are coming and ending here. It is not like that, it is not ending here. If there will be more paper, if the paper is more larger than its original size, then you will get these curves are also coming and ending here. Also here these curves are closed curve because the paper is not here, so you cannot see them, okay. So these are all closed but continuous also. Continuous means there is no breakage, completely continue means you cannot get a line that is here you will see here it is a curve, but now after some time the curve is missing here. You will not get anything like that, okay, you will not get anything like that. The curve is continuous. Another thing is the tangent at any point to the magnetic lines of force. The third point, the tangent at any point to the magnetic lines of force gives a direction of the magnetic field intensity at that point. Suppose I have considered this point. So at this point if I will draw a tangent, you know how to draw the tangent to a curve. That tangent will give you the direction of the magnetic field intensity. Now coming to the second point, why I told you about the third point? Because the second point is linked to the third point. Second point is they never intersect each other. If you see, as you know, when you draw a tangent, it will give you the direction of the field, okay. So I said that they never intersect each other. Why I said this? Suppose assume that a curve is coming from this magnet and it is intersecting each other, this curve, okay. So when they intersect, what will happen? They will have a common intersection point here. So when I will draw tangent to this curve and tangent to this curve, they are showing two directions. They are showing two directions. Whenever you see from a single point, they are showing two directions, okay. So which is not possible, which is beyond the law of nature, because a single point will show you only one direction. So okay, so that's why they will never intersect each other. So while performing experiment, if you see your curves are intersecting, that means you are going in a wrong way. You have to make it correct, okay. So now the number of lines of force per unit area is proportional to the magnetic strength, and the more concentration of lines represents stronger magnetic field. The more number of lines of force at a particular area, that means the field strength is more there. You know already from the properties of the magnet that the pole strength is very higher at the pole as compared to the center. So that's why from the pole it is natural that the more number of lines of force will come. And also if you consider two magnets of different shape and size, by looking at their lines of force you can say which one is stronger, which one is less stronger, because looking at the concentration of the lines of force you can say okay, this one is more stronger than this, okay. The fifth point is the lines of force tend to contract longitudinally or lengthwise. So because of this property, the unlike pole attract each other, because when you bring to unlike pole, their lines of force will tend to contract. They will contract lengthwise because they are forming a closed curve there. That's why this is the properties all about, that they contract longitudinally or lengthwise, okay. The sixth point is the lines of force tend to exert lateral or sidewise pressure. You can see from the diagram there are two north pole here, and when you bring them, their lines of force are trying to exert sidewise pressure. So because of this property we can say that the similar pole repel each other, and The last property is the 4 pi lines of force start from a unit magnetic pole. Unit magnetic pole means it can be a north pole or south pole, but 4 pi lines of force means you know the value of pi. If you multiply it with 4, you will get those many numbers of lines of force that will start from a unit magnetic pole.